All right, let's talk about loops. Loops in PCG are a little bit different than in blueprints if you're used to working with for loops or for each loops. It's almost like a function in some ways. So what we need to do is create a new graph, new PCG graph. So we'll go to PCG graph, and the default empty graph here will work just fine. Create empty graph. Let's call this one PCG neighborhood setup. And I'm going to be passing some data in and then plugging it into these nodes here. So I'm just going to copy everything between static mesh and procedural landscape data. Let's go ahead and open up our new graph. And I am going to paste it in. So you can see there are no default inputs or outputs. Let's go ahead and select our input here. Expose our pin data. So the label for now is whatever, it's fine. The pin status though, we want to set this to normal, and that'll just go ahead and make it visible. And then we want to set the allowed types. In this case, it's going to be point data. Let's go ahead and hit this little plus sign here. For the label on this, I'm going to call this one procedural landscape data. And you'll notice we're using a snake case, I think, where the first letter of every word is capitalized and it automatically puts a space in there. We're going to make the allowed types point because that's going to be point data. Let's go ahead and add another input. The label on this will be texture. The allowed types will be attribute set because this is going to be data that's coming in from a blueprint. We can add rotation here. Once again, that's going to be coming in from a blueprint, so it'll be attribute set. We'll go for color, attribute set, and then finally the name of each neighborhood. And this will be what we end up using for our new attribute names here. Set this to attribute set. For our output, it's going to be point data, and we'll just set this to normal. So now we've got an out there. So we can plug this in to that. Let's click on our Get Texture Data node and expand it, and at the bottom you'll see texture. So we'll just plug from the texture input into the texture override and collapse it. We'll grab our procedural landscape data and plug that into the point input here on our sample texture. This is going to be where our name is coming from, and you can see we're piping that into the output target as, in this case, neighborhood 1. I'm going to go ahead and grab that. We'll plug it into output target. This is just removing the roads. We can actually leave that there. This might actually make more sense just pulled out so we're not repeating this step over and over again. We can just do it in one step outside the loop. This is our rotation. So we can just plug like this. And just to add these little, I think these are called reroutes as well, but just double click it. You can go ahead and keep your graph clean. And then finally, we're going to use our color here. And I'll go ahead and add a couple more reroutes to keep it nice and clean. So now we have all of this stuff coming in, our procedural landscape data, our texture, our rotation, our color, and our attribute name. And we are not going to use any of the points that are coming in on our primary node. This is what we're going to use to control how many times we pass through the loop. So let's set that up now. Head back over to our primary graph. I'm going to drag our PCG neighborhood setup graph in, and then it's going to say, are we doing this as a subgraph or a loop? We'll select loop. All right, so this is what it looks like from the other side. You can see it kind of makes sense. There's our procedural landscape data, texture, rotation, color, and name. So we can kind of disconnect this stuff, and we'll just try to replicate it one for one. We're going to set up our blueprint inputs in a second, but we need to talk about this input here. So the way a PCG loop graph I think is expecting to work is I would be passing this data into the primary loop input here, and it would operate on each one of these points to do whatever logic we had set up inside the loop. But what we want to do is we actually want to use kind of a different number of indices to process all of this data in the context of our other inputs here. So we have to create some dummy points to pass in to our loop node here that will act as indices that we could use to access the texture, rotation, color, and name arrays on our blueprint. That might sound a little bit complicated, but once you see how it's set up, I think it'll be reasonably clear. Let's go ahead and add a points grid. By default, if I tap the A key, I think I'm going to get 100 points here. We can look at the indices, yeah. So that's, if I needed more than 100 neighborhoods, I would want to increase this. But in this case, we only need 12. So I'm going to add an attribute filter. And we're going to pass out all of the points whose indices are less than 12, because we're going to start counting at 0 here. And then we need to do one more thing. If I inspect this node, we can see there are points, but it all comes in as one group of points. So we need to add what's called an attribute partition node. And if I inspect this node, we'll see that each point now is handled independently. So this is what we will pass in to our input node. And this will basically run this loop however many times we are indicating here in our hard-coded double value of 12. Now we're getting a warning here because we're not passing anything in and we're running this a few times. So I'm actually just going to set this to 1 while we set up our blueprint. Let's go ahead and open it up. PCG City. I'm going to come over to the variables section and we'll go ahead and add one. I'm going to call this one textures. We need to set its variable type to texture 2D. We'll select this as an object reference. And because it's going to be an array, we need to set its data type to an array. Compile and save, and we'll make it visible so that it can be accessed in our PCG graph. Let's grab another one. Check my inputs here, rotation. So we'll set the name to rotations. And this is just going to be a float. It's a single decimal point number, but it will be an array. We have color and name. So for the colors, we can pick a color up here. We may need to make this a linear color, but for now we can try color and see how that looks. And then the next one will be names. And this is just going to be an array of strings. Let's go ahead and make sure these are all visible. Now in our PCG City graph, we can add a get actor property node. And what we're looking for is going to be textures. So come over to the property name. And we'll copy that into the output attribute name. Let's bump this stuff out of the way a little bit. Go ahead and duplicate this. The next one we will name rotations. Colors and colors. And then names. Let's go ahead and jump in to our PCG neighborhood setup loop graph here. The primary issue, or at least something we're definitely going to need to resolve here, is we're feeding in arrays directly into nodes that are expecting individual objects. An array is just a list. So what we need to do is we need to basically access the specific item in each of these arrays that each node here should be processing. In order to do that, we need to add a get loop index node. So every time we iterate through this loop based on our input points, this value is going to go up by 1. And we can use this if we come down to get attribute set from index. So I'm going to open this up and we will pipe in the index. And then this was our texture. Oops. So we can just feed this into our texture override. And it's currently unhappy because this doesn't have anything in it yet. So we'll add some things momentarily. But let's go ahead and duplicate all of this stuff. It's going to be pretty much exactly the same. We don't need to duplicate this. We can just reuse it. But for our rotations, and for our, what's the next one here? Color. And then finally, for our name. So the final step here to get this to work is to add something into each of these arrays. So I'm just selecting them. Go ahead and add one item. So into our textures array, go ahead and grab neighborhood 1. Rotations, I think we decided something like 5 works. For the color, we can select red. And for the name, we'll go with neighborhood 01. Let's compile and save. Make sure we're not looking at this one. So this one is disabled. This is now functioning. And there we can see the results. Let's go ahead and change the colors just to double check. We'll make it some other lovely color, yellow. And look at that. So now without having to duplicate everything down here for however many neighborhoods we want to create, we can just add array entries here in our blueprint, and the data will be propagated out through the graphs accordingly. I'm going to go ahead and add the rest of the data here to our arrays. All right, so we've got textures. The rotations are just set to 0. I've got some colors and everything is named. Let's go ahead and compile and save. And then I need to come over here and set this back. This is our filter here on our indices. Set it to 12. And here we can see our beautiful city laid out neighborhood by neighborhood so that we can easily come in here and tweak the rotations of the buildings so they align with our roads, which we will do in the next video.